answers to 5.5 day 1. We want to solve for these. So to get x by itself here, I'm going to add the 1 over. Sorry, subtract the 1 over. And divide by the 3. Okay, now when I have e here, remember I want to take the natural log of both sides, so those will cancel out. And lastly, to get x by itself, I divide by 2. So a natural log of 4/3 divided by 2. This one here, to get x by itself, I'm going to divide by 2 first. So this divided by 2 will be 2/5. Now, when I have a log function here, I want to take, with an not on the other side either, I want to take and write it as an exponent. So I know that 3 to the 2/5 will equal x. So x is equal to 3 to the 2/5. You could also write it as the 5th root of 3 squared. That'd be fine as well. Either one would be fine. Okay, next one there. If we just have an exponent here, remember we said we could take the log or natural log. Either way, I'm going to take the log function. I'm only going to use natural log when I have the e. Okay, so I know that log of 3 to the x is equal to log of 7. Using the product rule here, take the x out front. So this would be x log 3 is equal to log 7. And lastly, to get x by itself, I'm going to divide by this. So log of 7 over log of 3. This problem also asks us to put it into to the nearest thousandths. So it would be 1.771. And use Desmos to do this, right? Remember in Desmos, yeah, I mean you can type this in Desmos, but also graphically, if you just do actually 3 to the x minus 7, right, get it equal to 0, and see where it crosses, and you'll see exactly where it crosses there. Okay, number 12. We're going to take the log of both sides. So I know it's log of 1/3 to the x is equal to the log of 6. Bring the x out front. So it's x times log of 1/3 equal log of 6. So therefore x equals log of 6 divided by log of 1/3. Okay, if you put that into Desmos, the approximation of it is negative 1.631. Okay, next one. Same idea here. I'm going to take the log of both sides. Okay. Bring this out front here. This would be x minus 1 times log of 4. Bring this out front. This would be 2x times the log of 3. Okay, I want to get x's. Well, let's distribute it through. This would be x log of 4 minus log of 4 equals 2x log 3. Okay, let's get x's on one side, numbers on the other. Okay, so this would be x log 4 minus 2x log 3. I'm going to add this number to the other side, so log 4 on that side. Factor out an x here. So I have log 4 minus 2 log 3. And lastly, I'm going to divide by this. So my x will equal log of 4 divided by log of 4 minus 2 log 3. Okay, put that into Desmos, the approximation, about negative 1.710. Okay, number 18. Once again, log of both sides. Bring the power outside, so x minus 4 times log of 3. 2x plus 5, log 7. Should have left a little more room here, but we'll make it do. Okay, going to distribute this through. So this would be x log 3 minus 4 log 3, 2x log 7 plus 5 log 7. Okay. Now I want to get all my x's on one side, numbers on the other. So on this side, I have x log 3. I'm going to subtract this over, minus 2x log 7. Okay, on this side, I'm going to bring my numbers over. So I'm going to have 5 log 7 and add this over, plus 4 log 3. Okay, factor out an x here. And get x by itself here. So I'm going to have this divided by this. So 5 log 7 plus 4 log 4 over log 3 minus 2 log 7. Okay, and this one comes up to be approximately negative 5.057. Number 21, since I have e to some power, I'm going to use the natural log. So natural log and e cancel, so I just have the x minus 3 is equal to the natural log of 2 raised to the 3x. Okay, if I take this part here and bring the x, this up out front, would be 3x times natural log of 2, using the power rule. Get x's on the same side. So this would be x minus this term. And if I take this 3 and add that 3 over, I have this. Factor out an x, would be 1 minus 3 natural log of 2. And then divide. So it would be 3 over 1 minus 3 natural log of 2. Put it in Desmos, it's approximately negative 2.779. Okay, this one here, it's going to be no solution. How do I explain that? This would be 9 to the negative x, right? I can't have them equal to each other. I can't have a positive going to equal a negative here, so it's not going to work. Another way to think about it is if I would graph this, okay, if I add this 9 over to the other side, right, and have it equal to 0, the graph would look like this. There would be an asymptote here. So I know it's never going to come and cross at 0. So there is no solution to this one. Okay, number 27, I'm going to subtract the 1 over. Divide by 3. Okay, once again, take the log of both sides. Use the power rule, bring that out front. Distribute through. So x log 2 minus 2 log 2. Okay, I'm going to take this number and add it over to the other side. And I can divide by the x. Okay. Now, this would be acceptable. Now we can also simplify this stuff here too. for example, this part right here, okay, I'm going to take it and put it right here. Okay, so I know that this would be log of 33 minus log of 2 squared, right? 2 squared, which would be 4. I know when I subtract, it's like a division problem, right? So it'd be log of 33 fourths. Just looking at this and I made a mistake. So with this here, if this is minus 2 here, I need to add that over, don't I? So that's going to be a plus. Okay. So then, this part right here, this adding part, remember adding is like multiplying then. So 33 times 33 times 4 is log of 132 over log of 2, which in the calculator in Desmos gives you about 7.044. Number 30, I'm going to add the 4 over. I'm going to divide by the 3. Don't really need the parentheses there anymore. Which doesn't simplify, it just would be 64 thirds. Okay. Now, with the exponent here, I'm going to take the log of both sides. And take the x out front, exponent rule. And solve for x, I get x is equal to the log of 64 thirds over the log of 1.4. That's, the x isn't there because I took it out front, right? Over the log of 1.4. If you work this out to the decimal, it'd be about 9.095. Okay, now we're switching to log and natural log equations. Okay, so first thing, I'm going to get this by itself, so I'm going to divide by the 5. 10 divided by 5 is 2. The opposite of the natural log is e. Okay, so I'm going to say, I'm going to take the e to both sides, e to the natural log of x and e to the 2, right? Those cancel out, so I just have x is equal to e squared. Okay, doesn't say to put it in decimal form, but if you want to use the decimal form, e squared is like 7.389. Okay, number 36. We're going to take e to the natural log of 2x and e to the 5th. Both sides, e natural log cancel out, so I have 2x is equal to e to the 5th. To get x by itself, I just divide by 2 then. So I have e to the 5th divided by 2. Okay, number 39. Remember when I have log on one side, I'm going to use turn it to an exponent. So I can say 6 to the 2nd power is equal to 2x plus 4. So that makes 36 equal to 2x plus 4. Subtract your 4 and divide, you get 16. Once again, 42, same idea. Log equals something, therefore we're going to change it to exponent. So 7 to the 0 power, 7 to the 0 power is equal to x to the 3rd plus 64. Anything to the 0 power is 1. Okay, I'm going to if I subtract that over, it would be negative 63. I see what I did wrong. I turned that 65 to a 64 somehow. I don't know. Anyway, now if I bring this over, it'd be negative 64. That makes more sense. Now I can take the cubed root of both sides, and I get x equals negative 4. Okay, 45, addition, so I'm going to use that rule. So we're going to say it's log of x over x minus 21. Okay. With the log function, just a single log function, I'm going to turn it to an exponent. Remember, if it's common log, it means it's base 10. So I can say 10 squared is equal to my x over x minus 21. 10 squared is 100. 100 over 1. I like to use the cross multiplying idea. So if I multiply here and here, we know that x is equal to 100x minus that. Okay, I'm going to subtract this over, makes 99x. Add that over, 2100. What did I do wrong? I see what I did wrong. This is a plus, so that should not be divide, that should be multiply. That property. That foolish mistake. But mistakes happen, okay? Using the product rule, we have to, this is going to be log of x times x minus 21. Okay, now same thing, this is base 10, so I can say 10 squared is equal to x times x minus 21. 10 squared is 100, equals x squared minus 21x. Quadratic to solve. Subtract the 100 over. Factor it. And I get x is equal to 25 and negative 4. Okay, negative 4 is not part of the domain, so x equals 25 would be the solution. There we go. Number 48, we're going to use the quotient rule. Okay, so remember with subtraction, it is division. So we're going to rewrite this as natural log of 5 plus 4x divided by 3 plus x divided by 3 equals 0. Okay, so using that property. Now I can raise e to both sides. E and natural log cancel out, right? So if I go e to this side and e to that side, those cancel, so I'll just have 5 plus 4x over 9 plus 3x, if I distribute that through. And e to the 0 power is 1, right? So equals 1 over 1. Cross multiply, I get 5 plus 4x times 1 is equal to 9 plus 3x times 1. So I get x equals 4. Okay, 51, using the subtraction, the quotient rule. So this would be log base 7 of 4x over x plus 3 equals log base 7 of x. Okay, we had that rule that if they're both log base 7, I can just set these equal to each other. I know that 4x over x plus 3 has to equal x, which is the same as x over 1. Cross multiply. X times x plus 3 is equal to 4x. Subtract this over. Factor out an x. I get x is 0 and 1. Okay. 0 does not work. Okay, that's the asymptote area, so 1 is the solution. I'm going to pause this and think about this a little bit. Okay, I had to think about this one a little bit, but we can use this idea that, remember, if we have two, if you just think about, if we have 2 raised to the log base 2 of x, remember these two cancel each other out, so I just have the x. Okay, we're using that sort of idea here. So if I take 2 raised to the log base 2 of log base 2 of x and 2 to the first, okay, these two will cancel here, and I'm just left with log base 2 of x. 2 to the first power is 2. Okay, so these will cancel, and I'll have that is equal to that. Okay, so now I can just rewrite it as an exponent. So 2 squared is equal to x, therefore x is equal to 4. 57, we want to solve this graphically, so we want to get it equal to 0. Okay, so if I graph this, the graph looks like this. Okay, and I know my solution here is 4. Okay, so that's where it's equal to. When it's below, that's where it is less than, and when it's above, that's where it's greater than. So part A, we can see that x equals 4. For part B, we want to know where the equation is less than 0. So less than 0 would be from 4 through infinity. From 4 through infinity. And part C, where is it greater than 0? Okay, it doesn't start, so we have an asymptote here, right? So I don't really have values until I get to 0. So from 0 to 4. Use a graph to explain why this has no solution. Okay, so I'm going to take this and graph. I'm going to subtract the ln and 5 over, so I have it equal to 0. And I'm going to look at that graph, and it's not going to cross the x-intercept. Then 1 second, let me graph it. Okay, so by looking at this graph just here by itself would have an asymptote here at 0, but with the minus ln 5 here, that takes it down even farther yet. So our asymptote is down this direction, and this is what our graph looks like. So it does not cross x equal the 0. Therefore, there's no solution. Okay. That's the end. Come to class with some homework questions.